just with a number. But when I have a whole parentheses, we've got to multiply the whole thing. So let's first just review the distributive property. And this is yuck. I know this isn't nice, okay? This isn't a super huge deal, but we should talk about it in Algebra 1. When we multiply, we have to recognize the rules from last unit, okay? So this is multiplication. When I multiply that, that is a negative 6. G squared times G cubed is G to the 5th. Remember, I add those exponents together? So sometimes people get confused because they are like, why are you adding? We're multiplying. We are. It's that the rule for exponents is that you add them when you multiply G squared times G cubed. All right. Negative 2 times negative 2G squared times 6G would be negative 12G to the 3rd. Remember, because there's really a 1 there.
Oh, there is?
And negative 2G squared times negative 5 would be plus what? 10 what?
G squared.
Yeah.
3. 2? What?
Okay. Negative 5
yeah.
times a negative 2G squared. There's no G behind that one. Okay. All right. See if we can do these ones. We're multiplying them all together.
That is easy.
So 12 x to the what?
What? Wait, what?
X to the what? 4th. Y to the 3rd. How about that guy?
Whoa.
18 x squared y to the 3rd, because this is y squared and y.
Yeah.
And finally minus 15. Let's see, that would just be x squared y squared. Shane.
How come 1 is become x 4 and then the y is 3?
For which one? Which term? The first term? You want me to explain that one? Okay. So 3 times 6 is where I get the 18. X times x is x squared. Y squared times y is y cubed.
Wait. Isn't it technically an exponent on 6xy? So wouldn't it be...
This is an exponent. X squared. That's why I was using exponent.
There already be 1 there, so it'd be x to
X
the 3rd?
to the 1st times x to the 1st is x to the 2nd.
Too many x's.
Yeah, I know. It's a lot of x's. Not nice. Okay, how do we find products? So basically there's 2 ways. You can use something called extended distributive property or area, okay? I like area because I don't miss things. So basically, this has to do with the area of a rectangle. How do you find the area of a rectangle? Length times width. So basically the idea here is that's a multiplication symbol in between those 2 parentheses. So I also sometimes call this the box method. What I do is I make a box and I put one of my polynomials on, it doesn't matter, the top, and the other one on the side. So I'm going to put this 2x minus 3. Notice I did the minus 3 there, okay, on the side. And on the top of the box, I'm going to do my other one, 4x squared plus x minus 5. And then that's going to guarantee for me that I'm going to multiply all of the terms, because the idea with distributive is you have to take every term in the first times every term in the second. All right, so now I'm going to find the areas or length times width of each of these rectangles and add them together. What's 4x squared times 2x? 8x to the 3rd. What's 2x times x? 2x squared. What's 2x times negative 5? Negative 10x. Now let's go down to the rectangles on the bottom. These ones are going to multiply by a -3. What's -3 times 4x squared? Negative 12x squared. What's -3 times x? Minus 3x. And how about -5 times -3? Okay. What's also nice about the box method or the area method is now I add, these are all my little areas, and now I add them together. I just put like terms together. So what are some like terms that you notice? I see a -10x and a -3x. What else? I also see a 2x squared and a -12x squared. Okay, so this would give us, let's go in standard form. We have 8x cubed, 2x squared minus 12x squared would be minus 10x squared. Oh, and what about the x's? Minus 13x plus 15. All right. I want you to try one. So let's make a box down here. Let's make a 3x minus 4. On a top, would you make 3x squared plus x plus 2? Would you try that for me?
Let me get a line paper that goes with the this one.
What do you plug in the box?
Can you do that multiplication for me quick too? I just want to make sure you got it.
So, wait, okay.
I know it's very quiet. I think Bryce grew. You should measure him on the wall. Oh, they took away my marks.
Where?
I have marks on the wall. Like 3 feet and 6 feet.
Why?
Were they accurate?
Because I measure people. I measured Angel Martinez. Now, once you're done, then you just add like terms. So the box part is the multiplication. How did we do?
Good. I got them all right. Yeah. Wait, no. Wait, how is it x squared?
X times x is x squared.
Oh my god.
Well, yeah, gotta add your values.
got really
So
good.
when you're multiplying, the exponents change, right? But when you're adding like terms, those exponents don't change. You're just putting the things that are alike together. Okay, what would you do with something like this, do you think?
Give up.
Somebody not with no perseverance, somebody who has some perseverance, what would you do you think? Yeah. You could, there's a couple ways you could do this. You could do your box method for these two and then distribute a -2 to everything. Or before you even start, you could distribute the -2 to this, which would give you -6b minus times minus is +8 and b +2. Tell me about, I don't want to like totally go too far. Do you guys get the box method?
A little bit.
So I'm not going to do the whole thing, but what would be on the sides of this box then?
The sides?
The outsides.
-6b on top. Like, yeah, right
Yeah,
there.
or there.
And then 8 right there?
Yeah, and then b +2. Does it matter if you flip the box around? No, you could put the b +2 down here if you want. Okay, and then you'd go from there. So I actually never taught box method, and then my students said they really liked it because it helped keep them organized.
Pretty easy.
I'm going to show you how you do the same thing. You're going to notice I'm doing the same one up here with something called extended distributive property. And then you can decide which method you like best. So I'm doing the same thing over, but using distributive property. So the idea here is, how many terms do you see in that first parentheses? 2. So I'm going to distribute the 2x to everything. So this would give me 2x times 4x squared plus x minus 5. But then I'd also have to do or distribute the -3. So -3 times 4x squared plus x minus 5. So that's the idea of it, that you're just making sure you distribute all the things. If there was a third number, I'd add a third thing times the second parentheses. All right, and then we just do distributive property.
No.
Here we go. What's that? 8x cubed plus 2x squared minus 10x. Careful, this is a -3, okay? What would that term be? -12x squared minus 3x plus 15.
The box way is way easier.
You like box better?
Yeah.
That would give me 8x cubed. I still have, you're going to get the same answer. 2x squared minus 12x squared. That's some bad highlighting there.
I feel like it
Messy
takes
hand
us
there.
to do the box method.
You do?
Yeah.
Okay. We get the same result. Okay. So I wanted to show you that way too. These are the same examples, just doing that method. But I don't need to be redundant. When you start to get really good, then you can just use kind of a rainbow. And so what I mean is that you could do it separate, like you do the 2x and you just keep track of it with your marker, and then you do this, so you can kind of eliminate that in between step. I don't know if some of you are there. Some of you are already there, but some of you maybe shouldn't try to skip that step yet. So, okay, what do I have for you? Okay. So, oh, not 6 and 7, just 6.
I bet.
Yep.
Bet.
Just 6 is your homework. Okay, so guys, when you're doing this,